So you're headed back to training. Are you ready for the things that you probably haven't done since the last time? Let's get up to speed with this great piece from our very own Neil Singer. Ready for Recurrent 2.0. Neil?
Tower not available.
So we've just clearly lost our GPS. We've lost our synthetic vision, which is dependent on the GPS for input. We have a terrain fail message, TAWS also being dependent. We see a message right here, GPS not used. Depending on your aircraft, you may or may not have the ability to revert to DME position, depending on where you are and how many DME sources that you're able to pick up from the altitude and location on Earth that you are as well. So in this case, we still see that the FMS is navigating, but if it wasn't and we needed to navigate to the VOR using the VHF signal, we of course first have to switch our CDI source. The Garmin is telling us it doesn't like that. We've changed our nav source while we were tracking in nav mode. So this is one great reason to always fly with your heading bug synced. It's just one button push to put yourself in heading mode. The autopilot's not going to do anything unexpected. So now we're looking at green needles. We need to tune the station next. There's a couple ways we can do that. In our flight plan, if we tap the point to which we were navigating, we can tap waypoint info. We'll see the frequency. If we tap the frequency, we can decide where we want to put it, active or standby for nav 1 or nav 2. So let's put it in active of nav 1. Now we see right here that it's tuned to 117.5. It's already identified it as the MEM VOR, and we already have our DME information slant line distance being displayed. There's one more critical step though. We need to get the course to the VOR in. So you might remember from your instrument training, we twist the HSI. We're looking for a 2 indication on the flag and a centered needle. When that is the case, then we have the course to the VOR. The good news is Garmin makes this easier for us. When we start with a needle that we want to center, we can just push the course selector knob in. The system is going to automatically slew to the correct course. We have a 2, we have a centered CDI. So now we have green needles, we have the correct frequency in, it's been identified and confirmed, and we have the correct course. We can reselect nav. We expect to see VOR up here. Depending if you're flying a non-G3000 airplane, your status might say something different, but in the G3000 it's going to say VOR when lateral navigation is tracking the VOR signal. In a nose-high unusual attitude, it's really important. We don't want to just push the nose down with the wings level because we could induce a very low or even negative G-load. The airplane really doesn't like that. So we're going to keep this steep bank in. As we approach the horizon, we can start to bring the bank out. Now, if you notice your airspeed is particularly low, you might want to even let yourself pick up a bit more speed before you try to level off. When you're unloading the airplane, you're in a less than 1G situation. In that case, your stall speed is going to go down. If you suddenly load the airplane up as you recover to wings level and straighten level, you could find yourself encountering a stall. So be aware of where your airspeed is during the recovery. In a nose-low unusual attitude, it's very important while we're bringing throttle to idle, extending speed brakes, we roll to level. If we pull up in a steep bank, we're putting further stress on the airplane. The recovery is a balance between excessive G-load and letting the speed build up to a dangerous point, but we want to minimize that G-load by making sure we're wings level before we come out. As we approach a zero pitch reference point, then throttle and speed brakes as necessary to maintain straight and level flight. So we're here about 5 miles outside the final approach fix on our ILS 27 to circle to 18 right. You'll notice we're in nav mode here. We have localizer tracking, but we do not have glide slope armed because every circling approach is a non-precision approach. You note that the minimums are specified as an MDA. So even though we're flying this off of an ILS approach or off of an RNAV approach with LPV minimums, we want to fly it in nav, not approach, because in approach mode, alts won't be armed. The autopilot will track that glide slope all the way down, and of course we want to actually level off at our MDA. So on a non-precision approach, of course, we always want to be thinking ahead of the airplane. We're going to set our MDA now, 980 feet. We're configured for the circle. We have our gear down, our flaps are at the 15 degree or takeoff and approach setting, and we're tracking a speed of about 130 knots. That puts us squarely in the category C. On our map, this is a expanded protected area approach. So what that means is as category C, we have a minimum of 2.7 nautical miles of protected. So we can put our range scale here to 2.5 miles. As long as any part of any of the runways sits inside that ring, we are in the protected airspace when we're at MDA. And that's just going to help keep us aware of where we are, let us maneuver comfortably, and let us use as much of that protected area as possible so that we don't have a rushed circle. So now we're just waiting. We're approaching the final approach fix. We've already been cleared for the approach. And once we pass the final approach fix, we're going to select vertical speed. And sometimes on a non-precision approach, we will try to mock a 3-degree glide slope. So we might come down at 500-600 feet per minute, trying to do a continuous descent. On a circle to land, I'm going to use 1,000 feet per minute on the vertical speed. It's really to my advantage to get down to MDA as early as I can. It gives me more time to start trying to visually acquire the airport. It gives me more time to get my power reset so that I can hold my target airspeed. And it gives me more time to set my missed approach altitude, set my heading bug for the circle. There's a lot going on. So the earlier I get down, hopefully out of the clouds, in conditions where I can see the airport, it's going to be to my advantage. So here we are crossing Claiborne. I'm going to select vertical speed, 1,000 feet per minute. And trying to keep my airspeed at my target. Some of the airplanes we fly, even at idle, sometimes the airplane will gain a little bit of speed. If it starts to become excessive, we can use speed brakes, but if it's just a few knots, I wouldn't get distracted by it. So knowing that I'm going to be circling to make left traffic, I can set up my heading bug ahead of time. Every circling approach is unique. The geometry, the MDA in terms of how high it is above the airport. I'm going to say here maybe about a 60-degree cut to the right is going to look good, but I might change that depending on how the circle actually goes. Okay, I'm starting to see some ground a little bit, and I can see that my distance to the runway 27 threshold is 2.7, so I am in protected area now. I also have the runway in sight. So if told by tower to report the airport, I could do it at this point. I'm again inside this 2.7 mile protected airspace. The more of this area I can use without going outside of it, the more calm, relaxed, unhurried my circle is going to be. I've got the 2.7 miles. I want to use a good amount of it, while again still making sure I stay inside. Remembering that if pilots are going to err on a circle to land approach, much more likely to overshoot final than to undershoot, much more likely to roll out maybe a little bit high than a little bit low. I'm thinking about these things and trying to set myself up for success. So again, if I can use the full area, that's going to mean that if I am a little bit high, I have more time to correct it. Making sure I keep my landing runways in sight. Trying to stay on my target speed here. And I've got my track vector set to 60 seconds, which will show me in more or less instantaneous turn radius. So that's very helpful. That will tell me if I'm going to overshoot the extended center line, if I'm going to turn inside the extended center line. So making sure that your MFD is set up as mine is will give you the maximum amount of information, really make your job a lot easier. Okay, I've got the left and center runways and the right runway, just maintaining them in sight. So again, knowing that if I'm going to err, I'm more likely to err by turning too late. I'm going to compensate by maybe starting to turn a little bit earlier than I think I need to. If I see on here that, okay, you know what, it is a little earlier, I can always roll out a little bit shy of the bank that's being indicated. As I start my descent, I'm going to remember that the selection of the landing flaps will have a tendency to make me balloon. So I can select vertical speed down 500 feet a minute, 600 feet a minute. That's going to help keep me descending. Again, remembering that a common error is to end up too high. As I'm wings level on final, I can slow to ref. I want to be holding at least ref plus 10 with the landing flap selected through that final turn to give me a little bit extra margin overstall as I'm banking 20-25 degrees. And a good circle to land doesn't need to feel rushed. You should be able to maneuver, especially with that expanded circling area, so that you have plenty of time to get wings level on final, make small corrections as necessary. I can see on my synthetic vision, I'm on more or less a perfect 3-degree angle, even though I don't have a PAPI or a VASI. So I know my angle to the runway is good. My final gear and flap check, I'm basically right on my ref speed. Bring the throttles to idle. And again, there's no reason that this should be any more challenging to make my touchdown point and speed than any other landing.
These tips make simulator training even more beneficial. For more safety information, check out our free material at citationjetpilots.com. Click on the Safety tab. Fly safe, and we'll see you next time.